All right, we're back. Can you guys hear me now? All right. So where was I? I was giving some background on the current state of the indexer agent. So the agent takes the indexer rules as inputs, which is the indexer's strategy, essentially codified in a database table. And then it queries the network, gets lists of subgraphs, decides per subgraph, is that worth allocating to? If it is, it sends a transaction to the network to allocate to that subgraph. With that paradigm, it's basically making each decision in a vacuum somewhat. So it's looking at one subgraph at a time. It's deciding whether or not to allocate towards it or unallocate or reallocate, and then it's sending a transaction. It's doing this all sequentially, basically, and it might send any number 20 transactions if you decide you want to allocate to 20 subgraphs. So there's a lot of reasons this is not ideal. It can be kind of slow feedback loop. It makes it hard to run optimizers because the agent is only looking at one subgraph at a time, so it can't make a holistic decision and recalibrate the allocation amounts based on relative priority of different subgraphs and reward functions on each. It also makes it really hard for third-party tools to interact with the agent because if a tool comes up with a list of actions it wants to take, it can only apply those in an indirect way by sending rules to the agent. It can't directly send actions there. So what I did is I designed a new way for the agent to work where the agent is separated from the worker that is taking actions. So the agent is purely querying the network and deciding on actions, and then it sends those actions to a queue, and then a worker separately will pick up those actions and execute them in a batch if there's more than one, and those will be executed in a single transaction. So it batches them together using a multi-call function that we've added to the staking contract. And so now instead of sending one transaction after another, it can batch up any number of transactions up to thousands of allocation changes, populate the call data for those transactions, and send them as a single transaction execution. So this has nice properties of being able to make more holistic decisions and look across your set of allocations and decide what the amounts want to be. And it opens up a lot of design space for introducing third-party tools that optimize allocations, and they can send a list of actions directly to the agent to be taken in a single batch execution. So what I'm going to do is just do a quick live demo of the action queue so you guys can see how it works in action. And what I got here on my laptop is a local hard hat network. And I have the graph protocol contracts deployed here. I have a graph node. I have an IPFS node, and I have the network subgraph here tracking everything. So you can see on my local network, I have 5 deployments here that all have signal on them. And there's only one indexer, which is mine. And there are a few active allocations right now and a bunch of closed ones. And I'm going to go over to my indexer CLI and make some allocation changes. So what I'm going to do is go through the workflow here. So what you do when you're manually doing actions is you can use the CLI to queue an action. So I'm going to look here at my current allocations, and let's see, I'm going to reallocate to this subgraph here, 𝗀𝗲𝗂𝗧. And to do that, I supply the deployment ID and the allocation ID and the amount I want to allocate, 45,000 GRT. And that is going to add that action to the queue. But that action will not be executed yet. So what I can do now is add multiple actions to the queue. And so I'm going to also add an allocate action. and I'm going to allocate to a subgraph that I have not allocated to yet. So let me choose this one. Let's allocate 15,000 GRT. And then I'm going to maybe unallocate to 𝗀𝗲𝗂𝗋𝗃. Okay, so now I'm going to go look at my action queue and get everything with status queued. And by doing that, I can see that I have 3 actions queued up, an unallocate, an allocate, and a reallocate. And then to execute those, I'm going to approve them. So I'm going to approve them in a batch. I'm going to supply an array of action IDs here, 316, 317, and 318, and approve them. So those have all been approved. And then let's see over here, I have the indexer agent running. So you can see I just sent in this approve actions mutation. So those 3 actions have been approved. And then the worker loop should execute those shortly. Yeah, so here we go. So now what the agent does is it takes those actions and it does the process of preparing them. So if you're closing an allocation, it'll go to your graph node and resolve the POIs and get all data necessary to close the allocation, etc. And so it does those all in parallel. And you can see now that it's easier to track these actions through because there's an action ID associated with each log. So you can see it's preparing the transaction, it's resolving the POIs. And eventually what it does is it creates call data for each one. And then it puts that call data into an array, encodes that, and sends that as one transaction. So it is sending the transaction now, and that transaction is pending. So this is a lot easier to track through your logs. You can see the one transaction and the different action IDs. And this is going to save a lot of gas because obviously, especially if you're going to do a lot more, you can do thousands of allocation changes in one transaction. And it's going to take a few seconds to confirm. Let's see, was there anything else I wanted to show you guys here? Maybe while it's doing that, I'll ask for any questions here in the crowd.
We have a question virtually. So will it use allocate many underneath?
No, so there are the bulk functions on the staking contract that were existing. So there's allocate many and close that have been there for a little while. But recently was added a multi-call function. This allows arbitrary batching of staking functions. And so this allows you to be more flexible than allocate many because you can batch together allocations, close allocations, reallocate, as well as other staking functions eventually. Right now, it's just allocation changes.
And
then Meinhardt Soul has one.
There's another one. Meinhardt Soul has this question. So yeah, if you want to unmute the mic, Charlie.
Have you reactivated the mics?
Yes.
So you can do it too. And no, I mean the blocking of mics.
Oh yes. Oh yeah, I could do it.
Yeah, that's what I meant. The host
I
controls.
don't think did you.
Because I redeactivate the mics
Right.
for the audience.
So going back to the logs here, you can see that that transaction completed. Was successfully included in the block, and you get a list of what those actions were, and the data that returned back, and then I can go look in my action queue, and I can see for all these successful transactions that went through what the transaction ID was. And that's going to make it a lot easier to then go back and debug what happened. You don't have to go parse through all your logs and do extra work to do some debugging and detective work. So that's all going to be right there. The other nice thing is if the transaction had failed, it will log out the error to the failure reason. And so you can look at the DB and see why a transaction failed.
Will it tell you exactly which step failed, or?
It's basically printing out the error from the indexer agent. So I'm trying to make those as clear as possible, but it should tell you pretty clearly why that failed.
Revert message.
Well, yeah, so it could be it failed on the transaction itself. It could be it failed during preparation of the transaction. Maybe a POI wasn't available. Maybe that allocation got closed in the meantime, and it checks, oh, that allocation doesn't exist, so we can't reallocate to that. So it does some validation ahead of time, and it'll log out the reason why validation failed.
A lot of positive sentiment in the chat. Layerty is coming. This is so awesome. That's really good. We have 𝗨𝗀𝗳𝗂𝗟 who has this question, and I've given him the ability to unmute. So 𝗨𝗀𝗳𝗂𝗟, please unmute your camera.
Yeah, I was wondering how the execution order of a queue is determined. Imagine that, say, you have currently 0 GRT allocation available, and you do a number of transactions in the queue, and the end result should be that you have again zero GRT available, but the order in which it execute those might matter for actually be a success overall for all the actions.
Yeah, so right now, so these are all, sent in a single transaction. So the staking contracts do have revert checks on each one. And if one of them fails, the whole thing will fail. It's atomic. So that is one area that I'm going to do a lot more testing in the next week, and try to make sure that we can handle that better. But right now, the whole thing will basically fail, and you'll have to resubmit the batches. It's not really, you don't think of it too much as sequential because they're all being executed in one transaction.
But the order does matter. I do think it's quite straightforward, though. As long as deallocations happen first, then you make available the capital that would be required for subsequent actions.
Yeah, and so right now they're basically executed in the order that you add them or last update them. And I have a priority column in the action queue as well that's not really being used too much yet, but the idea with that is that if you wanted to override that order and decide that a single action has priority over others, you could change the priority number and bump that up to make sure it's always the first one above others. And definitely open to feature requests. This is something that I've been testing a lot, and I think it definitely works, but it's not on main yet. And definitely looking for feedback as soon as possible. Yeah.
If I wanted to basically take like a yield optimization dashboard and use that to automate allocations, is that something that we could perhaps get to in time?
Absolutely, yeah. So I think the next presentation will help clarify how another tool can work with it. But basically and thanks, good question, I didn't mention that. So with this change, I'm exposing a GraphQL endpoint on the indexer management server, which is already there. And it has a queue allocation method there that takes an array of inputs. So if you have a tool that you can then send the GraphQL request out to the indexer management server with all the actions that it has proposed, you can send those into the action queue. And then the flow that I would suggest is sending them in with the status of queued, and that would put them in your queue. And then you could use the CLI that I've just shown you to review all those and make sure that's really the actions you want to take, and then approve them, and then they'll be taken. Yeah. So the idea is to make that easy, to make it so like anyone can use whatever tools they have and integrate with the agent and send the actions proposed to the agent. Yeah, Chris?
First of all, this is awesome. And I think like the gas cost savings here are totally underhyped. Like this represents a material decrease in operational costs for indexers.
It's massive.
Yeah. So.
Yeah, I really want to. I'm excited to quantify that more.
Yeah.
Give you guys numbers on, based on a certain number of allocations that you're making monthly. What are the differences? Yeah.
Actually, that was my question.
I
Yeah,
imagine
I don't
that,
have numbers for you off the top of my head.
like this will
but
be
it's gonna be big.
50% easy.
Yeah.
With a decent number of items in the batch, it's big. At the very least, like every additional action in the batch saves 21,000 gas, just straight out of the box.
And there's more because they can share certain memory slots in the contract too.
wow.
So it's a little bit hard to quantify that like intuitively, but
It is big.
Also, you can time the gas market pretty well. Whereas before,
yeah, you can send
would
one
just go to gas,
transaction.
but then as they get executed one after the other, like, and the
Yeah.
gas shifts, and you're like, oh no, and you can't do anything about it. Whereas here, it's like, oh, good gas, boom, atomic transaction done, right? It's like amazing.
And it's amazing, like the preparation happens in parallel. So like all these transactions are ready to go in less than a second. And then the time you have to wait is just one transaction instead of like this long sequential process of preparing and sending and preparing and sending.
And hoping that the gas doesn't move.
Yeah.
So question, given that the multi-call capability exists purely within the staking contract, how does the action queue deal with interactions with the allocation exchange contract or generally other contracts in the system? And I'm thinking of two actions in particular, voucher redemptions and rebate claims.
Yeah, so right now this is only works for allocation actions. But I think a next step is trying to make this work with those kind of actions. And that's going to be, collaborating with RAL and the contracts team to see how we can support that on the contract side.
Pretty straightforward.
Cool. Yeah, that would be huge. I mean,
I
getting
think
more
that-
query fees, make it
Yeah.
reasonable for rational indexers to collect query fees is a goal that I have for sure.
Something that we've kind of thought about a little bit is if you basically, because obviously you can authorize operator addresses that act on behalf of the indexer. That's obviously how indexer agent works. If the address authorized is a contract, then that contract is capable of batching arbitrary calls across any other contract.
Yeah,
So-
I think that's a good option in the design space, is to have like sort of a proxy. You send the transaction through a contract that sends it through for you, and that'll allow us to do this across various contracts in the protocol.
Yeah, I mean, it even unlocks things like, I know, many of us running indexing operations obviously have tax liability on any income generated with the protocol. The moment you mint rewards, you have tax liability at the USD price at the moment of the disbursement. And so arbitrary cross-contract batching would allow you to automate selling the your tax liability percentage at the moment of disbursement. You take zero price risk. So it unlocks all sorts of cool things like that.
Yeah, that's a great idea. Cool. I want to hop off here so we still have time for the next presentation. We have just over a half hour left. Thank you all.